Alright, we're going to talk about volume of prisms and cylinders today. For the volume of a prism or cylinder, the formula is just area of the base times the height. So the only thing that really changes is what shape the base is. So if you know how to find the area of shapes, we just find the area of that shape and then multiply times the height of the prism or cylinder, and we have the volume. So right here, classify the solid below and find its volume. Well, this is a rectangular prism. Now, a rectangular prism is kind of unique in that pretty much anything could be considered the base because each side has a parallel and congruent side to it with a bunch of rectangles as the lateral faces. So we would typically just use the top and bottom since we can use whatever we want. So I'm going to do area of the base times the height. Well, the base, I'm going to use this rectangle down here on the bottom. So the area of a rectangle is always length times width. So for the area of the base, I'm doing length times width, and the length and width are 8 and 6. And 8 times 6 is 48. So I know the area of the base is 48. And then the height of the prism is 2. So we got 48 times 2 is 96. So the volume is 96. And in volume, it's a three-dimensional measurement, so the units are always cubed. So that would be units cubed. Okay, example 2 says find the volume of a cube below if each edge is 5. In a cube, all the sides are the same length. The length, the width, the height, they're all 5 because all the faces are squares and they're all congruent to each other. So really all I have to do for a cube is take the length of an edge and cube it to put it to the third power. So we can do 5 to the third power is 125. So the volume is 125 units cubed. If I was doing it the longer way, I would find the area of the base. 5 times 5 is 25 for the area of the base. And then multiplying times the height, 5 again, 125. So you just end up cubing 5 anyway. You multiply it times itself 3 times. Let's try example 3. It says classify the solid below and find its volume. Round to the nearest tenth if necessary. So if I'm looking at this first off, I see that it is a triangular prism. Anytime you see more rectangles than any other shape, it's going to be some type of prism, more than likely. And then anything that's not a rectangle, if it is a prism, anything that's not a rectangle would have to be the bases. I see 2 parallel congruent triangles. Those are the bases. So it's a triangular prism. Alright, so as I'm doing the formula for volume, first thing I always have to do is find the area of the base. Well, the bases are the triangles. Well, for area of a triangle, it's 1/2 times base times height. If I'm focusing on that triangle right now, I know that the base is 12, but what I don't know right now is the height. 8 is not the height because it's not perpendicular to the base. Height and base always have to be perpendicular to each other. Now when you got an isosceles or equilateral triangle, either one, and you draw that height then like this, it splits this side into 2 congruent parts. It bisects it. So 6 is half of 12. And then I can focus on this right triangle right here. I know 2 of the sides, 8 and 6. I can do Pythagorean theorem to find that third side. The hypotenuse is 8. That has to go in for C. 6 can go in for A or B. Does not matter which one. 6 squared is 36. 8 squared is 64. We subtract the 36, trying to get A all by itself. And then we take the square root. Got to get rid of that squared. You do the opposite operation, which is square root. So I do square root of 28, 5.2915, something along those lines, depending on where you're rounding it off to. Because I'm rounding to the nearest tenth at the end of the problem, I want to make sure I'm keeping a few extra places after the decimal point for now. So what I just found was the height of the triangle. So now I can find the area. I know the base is 12, and I just figured out that the height is approximately 5.2915. So when I multiply these, I get 31.749, something around there. And that's the area of the base. So we got the area of the base. All we got to do now is multiply that times the height of the prism. And the height of the prism is 4. Usually we're used to seeing the height be vertical, but that if the bases were on the top and bottom where we like to see them, then the height would be vertical. But if I tip it over on its side, these are still the bases, and the height is still what connects from one base to the other. So the height is 4. So I'm multiplying this by 4. I get something along these lines, depending on where I'm rounding to. And for my final rounding, I want to round to the nearest tenth. So I'm keeping one number after the decimal point. That next number, 9, is big enough to round up. Well, if I round a 9 up, it becomes 10. So I got to carry the 1 over. And I get 127.0. And volume's three-dimensional, so it's always units cubed. Let's try the next one. Classify the solid below and find its volume, round to the nearest tenth if necessary. Now it tells us the base is a regular polygon. Remember, regular means it's equilateral and equiangular. So on this polygon here, if this side is 5, I know all of the sides are 5. Okay, so how many sides does it have? It has 6 sides. A 6-sided polygon is called a hexagon. Notice all the rectangles going around, so I know it's a type of prism. So this is a hexagonal prism. And with any kind of prism, the formula is area of the base times the height. So the big job here is just finding the area of the base. For a regular polygon, the formula is 1/2 times the apothem times the perimeter. So we got a little work to do to be able to find the area of the base right now. Remember, the apothem goes from the center of a polygon to the midpoint of one of the sides, and it's perpendicular to that side as well. It's a perpendicular bisector. And if I draw the apothem and the radius in, along with half of a side, I end up with a right triangle here. I can find this central angle by taking the 360 degrees and one full rotation around a point and dividing it by twice the number of sides. This angle only faces half of a side. It would take 2 of these angles to face one side, so 2 for each side, so 2 times 6 is 12. So I'm going to take 360, divide it by 12, and that'll tell me what that central angle is, excuse me. So I know this angle right here is 30 degrees. Now that's going to help me because I should now, well, after I pay attention to the fact that this side is bisected, half of 5 is 2.5. I now have enough information on that right triangle that I can use trig, using with SOHCAHTOA, to find anything else I need on that triangle, which I do. I need this apothem. So I need to find this side. Well, if I'm using the 30-degree angle, the apothem is adjacent to the angle, and the 2.5 is opposite the angle. So opposite and adjacent uses tangent. So tangent of 30 degrees is equal to the opposite over the adjacent, which I do not know. So for the shortcut on that one, x is going to be equal to 2.5 divided by the tangent of 30. So 2.5 divided by the tangent of 30, x is equal to 4.3301, depending on where you're rounding to. So we have the apothem now. I can plug that into the formula. We just found the apothem. And what about the perimeter? Well, perimeter, we just take the length of the sides and multiply it times the number of sides, because remember, it's regular, so all the sides are congruent. So I have 6 sides. They all have a length of 5. So for perimeter, it's just 5 times 6 is 30. So I can plug the 30 in here for perimeter. And so when I multiply all these in the calculator, I'll find the area of the base. So there's the area of the base. And that was the majority of the work right there. I can take the area of the base and multiply it times the height. And the height of the prism is 12. Remember, the height will connect from one base to the other. The height is 12. So I'll multiply by 12. And then we want to round to the nearest tenth. So I'm keeping one number after the decimal point. A 2 is not big enough to round up, so those will disappear. I have a volume of 779.4 units cubed. Alright, last one. Classify the solid below, find its volume, and give the volume in terms of pi and round it to the nearest tenth. Alright, well, this is a cylinder. When you have two circular bases and a big rectangle going around the side, that is a cylinder. And when it talks about giving the volume in terms of pi and rounded, we've done a lot of rounding, so we should be comfortable with doing that. The in terms of pi allows us to give an exact answer, as pi is an irrational number. It's a never-ending, never-repeating decimal. So as soon as you multiply by pi, your number becomes irrational, never-ending, never-repeating. And so you have to round to write it down. There's no way. You can't write those numbers. You spend the rest of your life writing it and still never finish. So you have to round it at some point. This allows us to write down exactly what the answer is. This is approximate. It's close, but it has to be rounded, so it's not perfect. So here's how this works. For volume of a cylinder, it's still area of the base times the height. Okay, the difference here from some of the others is that the area is, the base is a circle. So area of a circle, the formula is pi r squared. So because of the circle being involved, pi has been introduced. We haven't had pi on the previous problems because those were all types of polygons. There was no circles, no pi. Alright, well, the radius here is 3, so we put the 3 in here for radius. Now I'm going to keep everything in terms of pi. The way I do that is I don't actually multiply by pi in the calculator. I do all the other work around pi, and I leave that number next to pi. So 3 squared is 9, so I'm just going to leave this as 9 pi. So the area of the base is 9 pi, and the height of the cylinder is 6. So just like I did over here, if I want to keep it in terms of pi, I don't actually multiply by pi. I'm going to leave the pi right next to the number to show that they need to be multiplied, but I'm not actually doing it. So all I'm really doing is 9 times 6. 9 times 6 is 54. So the volume is 54 pi. And this is in inches. Volume is three-dimensional measurement, so that would be inches cubed. Okay, now if I want to round that off, I can type it in the calculator. 54 pi is approximately 169, and it said round to the nearest tenth. I got 0.64. That 4 is not big enough to make that 6 round up, so 169.6 inches cubed. These are basically the same thing. This is exact, this is rounded, but otherwise they're the same thing, they just look different.